Hello, Mr. Bain here. This lesson is 2.3, Scientific Notation with Negative Powers of 10. Our essential question is how can you use scientific notation to express very small quantities? And our Common Core standard 8EE3 is using numbers expressed in the form of a single digit times an integer power of 10 to estimate very large or very small quantities, and so on. So if you have seen the previous lesson or learned it, you know that we dealt with very, very large numbers, sometimes in the millions or billions or trillions, and we can write those in scientific notation and then back into standard form if we had to or wanted to. So now we're going to be dealing with very, very small numbers. We're talking about numbers that are less than 1, that are like 0.000000001. Okay, it's a very, very small decimal number. In that case, it's going to give us our negative powers of 10 when we have that small number. So let's take a look at this example here that's on the front page. A typical human hair has a diameter of 0.000025 meters. Write this number in scientific notation. So it actually shows you this list comparing the number 1.345 with different powers of 10 just to see how it looks. So I'll let you kind of look through that and see if you can find some kind of pattern. Even fill in the blank if you wanted to. But let's go ahead and go to part B. Part B says move the decimal point in 0.000025 to the right as many places as necessary to find a number that is greater than or equal to 1, less than 10. What number did you find? So I'm going to write this number first on the right side. Then my decimal point is already there. It's near the left side. So I need to move it all the way until I get a number that's between 1 and 10. And I can move it right there. Yeah, that's the only place I can move it. I end up with 2.5. Putting it anywhere else won't give me a number between 1 and 10. So it has to be there. Again, I could divide my original number, which is this, divided by 2.5 to get my power of 10. But I'm not going to do that. What we can actually do is just count how many times I moved it. So I moved it 1, 2, 3, 4, 5. And because I started off with such a small number, this is going to be a negative exponent. So that's how you can remember. Super small number means my exponent of 10 is negative. So when we combine those two parts, the 0, I'm going to write out this whole thing. 0.000025, and that's standard notation, is equal to 2.5 times 10 to the negative 5th power. Okay, and that's it for changing standard notation to scientific notation when the number is really small. Next page. The top box, writing small quantities in scientific notation, again, is a good little reference for you if you just needed a quick reminder of how to do this. It gives you an example and an explanation of what to do. Let's scroll to the bottom of the page to try the your turns. We got 3 your turn problems. If you feel like you're ready, go ahead and pause it, give it a try, unless you want to see at least one of these first. Number 4. I'm actually just going to use a number right here instead of rewriting it. I'm going to move this decimal point as many times as I need to until I end up with a number that's between 1 and 10. And I get 8.29. I look at how many times I moved it. Let's see, 1, 2, 3, 4, 5. Since I started off with the super small number in standard notation, my scientific notation has a negative exponent. Number 5. 1, 2, 3, 4, 5, 6, and 7. My scientific notation number, 3.02 times 10 to the negative 7. Number 6, a typical red blood cell in human blood has a diameter of approximately 0.000007 meters. Write this diameter in scientific notation. So I need to move this decimal point over all the way till I get past the 7, because that makes it 7 on the dot. That 7 is between 1 and 10, so it works. And then times 10 to the, let's see how many times we moved it. 1, 2, 3, 4, 5, 6. So 10 to the negative 6. And that is now in scientific notation. Let's now practice going the other way around, converting from scientific notation to standard notation. Next page. Scroll to the bottom. If you want to read through this example, it's definitely a good resource. But let's go straight to the your turn. This first number, 1.045 times 10 to the negative 6. It's important that negative 6 means that the number is going to be really small when it's in standard notation. So I'm just going to write out 1.045 first here above. And I know I'm going to make this smaller. So you can just do this to remind yourself. How do I make 1.045 a smaller number? Am I going to move the decimal point to the right? Or am I going to move it to the left? Okay, so just ask yourself those questions as you're doing this. To make it smaller, in standard notation, I got to move it to the left, right? 1, 2, 3, 4, 5, 6. My new decimal point is right where I ended. That's my new decimal point. And that means that my blank spaces are going to have zeros. And my solution is 0.00001045. Okay, if you haven't tried any on your own yet, please pause it. Try number 10 and 11, and then you can check out the solution. Number 10, you're going to end up with, I'm not going to show the working or anything for this, but you're going to end up with 0.000099. It's a preference of mine, but I like to see the 0 in the ones place. If you don't put it there, that's okay. Sometimes having that 0 there will help me see the decimal point a little bit easier. Okay, so just a heads up about that. It's okay if you don't put it in the ones place like this, or if you do. I prefer this way. And number 11, we're going to end up with 0.01 meters as our solution. That is going to be it for this lesson 2.3. Thank you for watching. Have a good day.